Hey, welcome back, AP Calculus students. Today we're looking at 5.4 Modeling and Optimization Part 2. So some things that you might need to know if we're running a business or manufacturing stuff, that R of X represents revenue. That means how much money you're getting in from selling the items. C is the cost, meaning how much it costs to make an item. And then P of X is profit. So we calculate our profit by taking the revenue, how much money we took in, minus the cost it took to manufacture that product, and then we get our profit. So two other things also to note is R prime of X is the marginal revenue, and C prime of X is marginal cost. That'll come up as we're doing our theorems. So the max profit, so obviously when we have a business, we want to find out how to maximize profit. We want to make as much money as we can from the thing that we're manufacturing. So the maximum profit occurs where marginal revenue is equal to marginal cost. So that means that the R prime of X is equal to the C prime of X. So let's just jump into an example here. It says that the R of X is 9X, the revenue, and the cost is X cubed minus 6X squared plus 15X, where X represents thousands of units. Is there an amount that maximizes profit? All right, so what we're going to do here is we're going to do, because we're asking to maximize the profit, we're going to find R prime. So R prime of X is just 9. C prime of X would just be 3x squared minus 12x plus 15. And the maximizing the profit, we're going to set these two numbers equal to each other. And then we're going to go ahead and solve for x. Okay, and then we can factor out a 3 here, so let's do that. 3x squared minus 4x plus 2. That's not something we can factor, so we have to go ahead and put it in our quadratic. Alright, so let's go ahead and do that. Our A is going to be 1, B is negative 4, and C is 2. So we have 4 plus square root 4 squared minus 4 times 1 times 2 divided by 2. So we get 3.414. And also if we do the minus, we get 4 minus square root 4 squared minus 4 times 1 times 2 divided by 2, 586, 0.586. Okay, so there's actually two amounts that maximize profit, right? One at 3,414 units, and then one at 586 units. And we said that this is equivalent to these because we're talking in thousands of units. Okay, theorem 7 says minimizing average cost. So if we want to minimize the average cost to produce something, it says that we're looking for the production level where the average is equal to the lowest. So maybe we shouldn't underline those things as much as doing this. Average is equal to marginal. So the average means we just take the function divided by x, right? That'll give us the average over the interval x, and then we find the marginal, which is the derivative. Okay, so for this example, we have x cubed minus 6x squared plus 15x. So again, x is thousands of units. So we're trying to find the amount that minimizes average cost. So we're going to do C of x over x, right? This is the average. Okay, so that's going to be x cubed minus 6x squared plus 15x divided by x. So that just means that each of those x's is going to be one less. So we're going to have x squared minus 6x plus 15. And then we're going to do the marginal cost, right? So c prime of x. And that means the derivative. So we have 3x squared minus 12x plus 15. And we're going to make these equal to each other. Right, so x squared minus 6x plus 15 equals 3x squared minus 12x plus 15. We're going to subtract here. Move them all to one side. So this is going to be 0. On the right side, 3x squared minus 1x squared is 2x squared. Negative 12 minus 6 is negative 18x. And then 15 minus 15 is going to be 0. Okay, so let's do some factoring out here. We can factor out... Oh, sorry, this should be a plus 6. Plus 6. So this should also be 12. Negative 12 plus 6 is negative 6. Okay, so let's go ahead and factor. We can factor out a 2x from both of these terms. So we get an x and we get minus 3. So zero product property says if we have two things multiplying, in order for it to equal to 0, one of them's got to be equal to 0. So x would be 0 for the 2x, and then x would be 3 for the x. Now, let's think about this practically. Right? If we have 0 product, is there any way we can minimize cost? That doesn't make sense, right? I mean, yeah, it's going to be minimized cost because we're not making anything. So actually, the real minimum would be 3. So we'd want to make 3,000 units. Okay, so good practice, and also good practice in at the very end thinking of if our answers make sense, right? 0 units doesn't make sense for us to manufacture because that means we're not even manufacturing anything. Okay, so that's it for today. Good job.